that x there. All right, and the big change on that would be the original answer I had was, so after I worked out the original one, I came up with 3x squared plus 5x. I think I had plus 3 on the answer key. That is not correct. It would actually be a plus 2 if you did it correctly. Because when you distribute this negative in for this 1, it actually would have been, instead of the 3, I subtract 1 from that 3, which would give it 2. Everything else is the same. So if you look at the answer key, everything else was the same except for that minus 1 at the end. The other mistake was actually on the first one of the graph. I kind of rushed through it. I had, for that x is less than or equal to 3, I actually had that as negative infinity to 3, but I should not have used a parenthesis. I should have used a brace. Same thing on the graph. I should have had a brace at 3 going this direction. So I should have been brace instead of parenthesis. That being said, the 2 mistakes. Are there any other questions from the answers? Aiden? 57? Well, 67? All right, for 67, we are inputting. So we have 2 things we have to do. We have to input x plus h into our f function. So let's do that first. That would be 3 times x plus h squared minus x plus h. And then we're going to subtract away, plugging x in for all of those x's. Well, that's just going to stay the same. So that's 3x squared minus x. Then we'd have 3 times x squared plus 2x h's. Yeah. Plus h squared. Distribute the negative side. I'll negative h, x minus h minus 3x squared plus x. I'm going to notice that this and this are going to cancel out. Now when I distribute that 3, I'm going to have 3x squared plus 6xh plus 3h squared. I still have, so I got rid of this, I got rid of this, so I'm just left with that negative h minus 3x squared. This 3x squared and this 3x squared are going to cancel out. So I am just left with, yeah, I got the right answer, 3h squared, sorry, plus 6xh minus h. So there's just a lot of moving parts to plug in. Other questions? Yeah?
Could you factor out an h and put that all in parentheses?
Factor out an h? Yeah.
Okay.
Yeah. So you could rewrite this as h times 3h plus 6x minus 1. That's what you're asking? Yep, that's fine. Yeah.
There were some of like the graphing ones that didn't have answers. Is that because you're gonna check it in class? Or?
Which? Oh, just one of them, right?
I thought it was like 2, like number 2 and number 5.
Number 2. Oh, yeah. I figure you can do them.
Okay. I just want to make sure I was like.
Yeah. No, I guess I left those blank. That's okay. You can figure those out. Other questions? Okay, then today we're just moving into, so we're going to move into more domain range graphing and increasing, decreasing, and constant aspects of a graph. So the first thing we're going to do is we're just going to graph using a table. All right, usually when we have x squared or something like that, a good thing to do if you don't know what the shape looks like, do -2, -1, 0, 1, 2. If you feel like you didn't get what you wanted out of it, then expand your search to -3, 3, -4, 4. But our first one is we are inputting a -2. So our input is -2, so that's our domain. When I plug in a -2, we have -2 squared, which is just going to equal 4. So when I plug in -2, I get out a +4. When I plug in a -1, I get out a +1. When I plug in a 0, I get out a 0. When I plug in a 1, I get out a 1, and finally when I plug in a 2, I get out a 4. Let's do this first without graphing. Let's do the domain and range without graphing, and then we'll talk about if I have a graph, how do I get my domain and range. From yesterday, we said the domain is my input. It is what values I'm allowed to plug into this thing. In other words, what values are okay for this x here? Yeah. Negative infinity to positive infinity, because there is no number out there that's real that you cannot square. Right? I could square negative 1 billion. I can square a positive 1 billion. I can square negative 2.773114. I could square pi if I wanted to. I could square any number, plug in your calculator, you get an answer. So that is the reason why our domain is negative infinity to infinity. Range is a little different. I know I can plug whatever number I want in. Am I going to always get out every single possible value? In other words, what number can you square to get a negative out? None. So can you ever get 0 out? Can I plug in a number and get 0 out?
Yeah.
What?
0.
0. Can I plug a number in to get a positive out?
Yes.
So what's the only thing we can't get out? A negative number. So that means our range is going to be something from 0 to infinity. Because we can't get out a negative. No matter what I plug in the domain, I can't get out a negative. Now let's see what that looks like graphically. So we're going to graph all those points. That's negative 2, 4. I think my graph looks just a little different than yours. I have negative 1, 1. I have a 0, 0, 1, 1. And I have a 2, 4. That is that parabola we know and love. Well, domain is our input. So if I just gave you this graph and I asked you for the domain, I didn't give you the function, I just gave you this graph. What you're going to think about is domain is our x values. X values run left and right. So when I ask for your domain, I'm asking you how far left does this graph go to how far right does this graph go. All right, I'm just looking at left to right. And what I do a lot of times, especially on something like this, well, this graph goes left forever, right? And it also goes right forever. So what I'm going to do is I'm going to, underneath it, I'm just going to say my domain runs this direction, and it runs all the way across from left to right. So that is negative infinity. Maybe I could put an arrow on this side. Negative infinity all the way to infinity, because we read from left to right. Our range, though, doesn't go from negative infinity to infinity. Our range is how high or how low to how high the graph goes. Lowest value to highest value. Well, range starts at that 0, goes up. That's my range. And it goes up forever. So my range starts at 0 and goes up forever. So I should have 0 to infinity, which I did. So the graph just reaffirms the fact that I did this right. Guess what? You have awesome powers in your hands. You have an awesome calculator. So if you're ever really struggling for domain and range, just graph it. And you have this awesome thing called Zoom Fit. So if you know how to read a graph, you have this graphing calculator. So if you're ever on, like, I don't know, ACT, SAT, something like that, and you're just not sure about what domain and range is, just graph it. Graph it and see what I think that's probably some of the easiest ways to figure out your domain and range. All right, any questions on that? All right, I want you to do the next 2. Do the next 2, and then you can try that 4th one on the back. But if you're not sure how to do it, just don't. Otherwise, you're going to end up erasing stuff. So you are now in charge of the next 2. I'll do that right now. So a good point is, on that first one, you have to do square root of negative 2. I can't do that. The only thing I can do is I can put an imaginary number, but then we're talking about plotting on an imaginary plane. I don't have an imaginary plane up here. So yeah, I'm just going to put like UND for undefined. you can just cross it out and say you can't do it, something of that sort. But you cannot plot that point. All right. So the first one, we're just taking square roots of the values. I am taking the square root of -2, that's undefined. The square root of -1, that is also undefined. Hold on, guys. I'm talking right now. You had you. Square root of 0 is going to be 0. Square root of 1 is 1. Square root of 2 is 1.4 about. Square root of 4 is 2. Square root of 9 is 3. So plotting those points, you can't plot anything that's undefined. So I'm going to plot 0, 0, 1, 1, 2, 1.4-ish, 4 is 2, 9 is 3. So the graph of a square root function looks like that. Now our domain, looking at the graph, our domain goes left to right. Our domain starts here and goes this direction. So our domain is that. It goes from 0 to infinity. So our domain, including 0, goes to infinity, which makes sense. You can't plug a negative in here. You can't plug a -1 in for x because you get an undefined. So it has to, our lowest value is 0. Our range, I would probably write this on the right side. I just don't quite have the room, so I'm going to do it on the left side. Our range starts here and goes up. And it actually goes up forever. All right, so our range is going to go from 0 to infinity as well. Which also makes sense, because if I can't plug a negative in, I'm most likely not going to get a negative out. Our cube root. Some of us had to brush up on our cube root. Hey, you can use your calculator to calculate a cube root. You have a cube root button. If you go to your math button, there actually is a cube root in there. If you don't want to go to your math button, or you have a calculator that doesn't have a cube root function in it, just rewrite it. Rewrite the cube root of x is actually x to the 1/3. So I could do -8 to the 1/3, making sure I'd use parentheses correctly. We're going to come up with a cube root of -8 is actually -2. Because -2 times -2 is +4, times a -2 is a -8. All right, the cube root of -1 is -1. The cube root of 0 is 0. Cube root of 1 is 1. Cube root of 8 is 2. Applying those points, I have -8, -2. I have -1, -1, 0, 1, 1, and 8, 2. Connecting those dots, I'm probably not going to use straight lines because that's ridiculous. So we're going to do something that looks like that. And we'll have this guy going like that. Our domain is left to right. Can someone give me the domain of this one? Luke?
-infinity to positive.
It is -infinity to positive infinity. -infinity to positive infinity. In other words, I would start way on the left. Way on the left. I guess I can put an arrow there. I usually just drag it left to know I go left to right. I know domain goes there. Range. Can someone give me the range? Yeah. -infinity to positive infinity. I'm going to do this in red just because I don't have all that room off to the right like you guys should. But if I was doing my range, I'd probably put it on this right-hand side and go ooh. Those are the exact sound effects you should make. That would be my range. And that would keep going up forever. And I guess I could put an arrow going down. It goes down. Range, domain. Domain left to right, range low to high. Don't forget about domain and range. People really struggle with those when we get to a test. When we're doing it in class, like, yeah, I got it. Then they do homework, I get it. And then you get to the test and people just like freak out and they just make up values. All right, so understand domain and range. These should be easy problems. Don't spend your time on these ones. Yeah. I pretty much get that sometimes. All right, this one. See how it's x equals y squared. You can rewrite it in terms of x. It's not the most effective way because sometimes you can make little mistakes. If I was to rewrite this, I'd have to rewrite it as y equals plus or minus square root of x. which would mean if I wanted to graph this in my calculator, I have to graph y equals positive square root of x, and you'd have to graph y equals negative square root of x to actually get this whole thing. Because it's so hard to plot it in my calculator, you should know it's kind of a weird function, if it's even a function to begin with. So something weird is going to be happening. Whenever you have to do something to y to get out x, all right, we're not switching things. This is still my input. The y is still my output. All right, it's still, our x is still our domain, and our y is still our range. However, sometimes these are easier to do backwards. I'm actually going to come up with my output. I'm going to come up with my output column first, and that will give me my input column. What I mean by that is I'm going to focus on my y's. I'm going to focus on my y's, and I'm going to do -2, -1, 0, -1, and -2. So I'm going to work backwards. I'm going to say if my output is -2, what's my input? Well, to get my input, I'm just going to take -2 squared to get me 4. So it's almost like I am inputting it, but it's the wrong terminology of what's happening. But you are placing that -2 in place of y, squaring it to get your x value. -1 squared is going to be 1. 0 squared is going to be 0. -1 squared is 1. -2 squared is 4. Reminding you that this is my domain and this is my range. Without graphing it, is this a function? Without graphing it, is this a function? Nick?
No.
No, how do you know it's not?
Because 4 goes to -2 and 2, and 1 goes to -1 and
Yep.
1.
I'm just going to focus on your first one, that 4 and where it goes. So in my domain, I have a 4. That 4 has to map to a -2, and it has to map to a 2. So if that was a letter, you have to tear it in half and put it into 2 mailboxes.
You wrote
Yeah, I see what I did up there. I see what I did up there. Those should have been a +1 and a +2. Okay, so that is not a function. And I'm actually going to write that. It's always good to recognize when something's not a function. Because a lot of times on tests and sometimes in homework and stuff, I will say if it's not a function, you don't have to do anything else after. All right, so I might say, do all this work, but if it's not a function, don't do it. So learn how to recognize if something's a function or not, because I might even said if it's not a function, you don't have to graph it or do anything. In which case you'd be done versus somebody didn't realize and had to do a whole bunch of graphs and a bunch of extra work. All right, let's go ahead and plot this though. So when x is 4, y is -2 and 2. So let's plot that at 4. It's -2 and 2. At x equals 1, we have -1 and 1. And finally at 0, we just have that 0. Wait. I put the 2 in the wrong place. There we go. Nikers, that looked off. All right. At 1, it was 1 and -1. I just plotted in the wrong place. All right. So that's going to look like y squared, unless something weird happens, is always going to be a sideways parabola. And it will always be a non-function. And it's a non-function because of what we wrote over there.
Vertical line test.
And we could learn by the vertical line test. But the vertical line test is the exact same test I put underneath it, where x equals 4, y equals 2, and negative. So this is the vertical line test. Algebraically, that's my vertical line test graphically. All right. A lot of times I might say if it's not a function, you don't have to find the domain and range. But in this case, we are going to find our domain because we're good at it now. What's our domain of this one? Luke?
0 to positive infinity.
0 to positive infinity. Bracket or parenthesis? It's bracket for 0. Infinity always has a parenthesis. All right. Who can give me the range? Nick?
Negative infinity.
Negative infinity to positive infinity. Awesome. That's domain. That's range. That's how to plot things right now. All right. The next thing we're going to talk about is increasing, decreasing, and constant. and we're going to introduce the math superhero named Pierre, the mountain climbing ant.
Any relation to Adam?
No.
Not at all?
They don't like each other either.
Really?
I know.
Is Adam
Well, kind of. He just spins around in a circle. Pierre likes to go places. You know, they're different types of personalities.
Is that why it was such a shock when Adam was on the moon?
Yep.
That was so funny. That was great.
Adam was on the moon. That was like the second day of school.
All right. Pierre is his superhero strength is he can walk across your graph. Problem is he only can walk left to right. That's why we always read graphs left to right, because Pierre can only walk left to right. That's fact.
To him, he was walking forward.
So Pierre only walks left to right. So when we're talking increasing, decreasing, and constant, always think left to right. Otherwise, you don't know if something's increasing or decreasing because you wouldn't know. It just depends which direction. No, we go left to right when we're judging these things. All right, left to right. If while walking left to right, Pierre is going uphill, so he has to climb, that is increasing. So he's increasing here, and he's increasing here. He's walking left to right. So these two intervals are where it's increasing. How we list these intervals? We have to use x values. Because Pierre is walking left to right, the only way to talk about left to right is x values. All right, x values go left to right. So we're just going to use x values, and we're going to use parentheses. So the first interval where Pierre is walking uphill, he's walking uphill from negative infinity, that's a long walk, all the way until negative 3. Left to right using x values. Now he's walking uphill somewhere else, so we're going to use a union sign. He is also walking uphill from 1 to 4. And those are the only two places that Pierre would have to walk uphill.
Did he jump?
No.
How did he get from -3 to 1?
He's pretty good. All right. Why do we use parentheses instead of brackets? So let's talk about that real quick. Why do we use parentheses instead of brackets? So notice I didn't use any brackets. And here's what I'm talking about. Quick. Oh, got a reason? No? Cool.
Is it because where the points are, it's not going up or down? It's perfectly balanced.
You need 2 points of reference to know if something's going up or down. At, say, x equals 1, if Pierre's standing on x equals 1, he's not going uphill or downhill. In other words, picture this. You're on your final, and I'm standing here, and I say 100% of your grade is determined on this next question. Am I walking forwards or backwards? But I'm just standing here, but I make you do one. Would you know for a fact which direction I'm going? No, you'd say neither, right? Until I take a step, you don't know if I'm going forwards or backwards. So, at one point, Pierre is never going uphill or downhill. He's going uphill from 1 to 4, but at 1 and at 4, he's neither going uphill or downhill. So you always use parentheses. So here's the big thing. Here's the big thing about increasing, decreasing, and constant. If you get these right, you'll get almost all of these right. A, you read the graph left to right. B, you use x values. And C, you only use parentheses. Why that gets confusing is because in domain and range, you can use brackets. But with increasing, decreasing, and constant, you can never use brackets. It's always parentheses. So once again, left to right, x values, parentheses. You do that, you'll get these right. You mix that stuff up and you've got problems. So make sure you got notes or you know what's going on.
Wait, will you say those one more time?
Yeah. Left to right, x values, parentheses. All right, so we already know where Pierre is going up. Now let's talk about where Pierre is going down. Pierre is going down. Remember, he's going left to right. He's going down if he's ever doing this nice like slide action. He's going to there. All right, where he's going downhill from left to right is where it's decreasing. So on this graph, he's only decreasing from that -3 to that 1. So once again, left to right, x values. So that's -3 to a positive 1.
It's so weird to decrease from a negative number to a positive one.
Right, but you have to think left to right.
Yeah.
All right? Yes, it looks weird. Last thing I'm going to talk about is constant. He's not going uphill or downhill. That doesn't mean I'm going to count all of these points. All right? Nothing is happening at -3. Nothing's happening at 1. You need at least 2 points to know if you're increasing, decreasing, or constant. So the only place PR is constant is at 4 to infinity. Because that arrow just keeps going and it's still flat. So don't ever say, right, at 1, you're not going to say that's constant. Because it's not. It's actually in change. He's changing from going downhill to uphill. It's a changing point. So nothing's really happening there. Yeah.
Just a question.
Yeah.
I get why we use parentheses on the others, but
Mhm.
why do we not use bracket on the 4 here?
Same exact statement. Is he constant or is he going uphill at 4? Both. Technically it's both or neither. Right? It depends on which way you're looking. Is he continuing going up or is he? So you will never ever use brackets because at that one point both things could be occurring or neither could be occurring. All right? So we always use parentheses.
Oh, because you could still be going up at point. Oh, okay. that
Yep.
makes
We don't know until there's another point after it. Just like if I just cover up this graph, you know, if from here, we don't know what happens on this side of it. If I cover it up, it could be going up or down. Just know it's always parentheses. All right, you're in charge of doing this next one. I'm only going to give you a couple minutes. It shouldn't take super long. I want the domain, range, increasing, decreasing, and constant. Like I said, just a couple of good points. They aren't all negative. That 2 should be positive. That 3 should be positive. So like this should be a positive 4, positive 6. Negative 4, negative 6. All right, I want to get this done as quickly as possible so I can check your homework. So if you're not done, that's okay. Just try to stay along with you. If you are done, help out. Because the faster we get this done, the faster we can just work on a little bit of homework. All right, first thing, domain. What is the domain of this function? Luke.
negative infinity to positive infinity.
It is negative infinity to positive infinity because this goes all the way left forever. And it goes forever that direction as well. So our domain is negative infinity to infinity. Range is a little trickier. Who's got the range? Nick.
-3 to positive infinity.
Ooh, nailed it. I'm going to put a bracket on -3 because it includes it. To infinity. The trick here is, and it's sometimes hard, especially if you're in a test and you're just quickly looking at it, a common mistake is -3 to 3 because you just see the high and low. Make sure you look for that infinity way on the left-hand side. So it is -3 to infinity. Where is it increasing? I need one increasing from someone. Jack.
-5 to -3.
-5 to -3. I should use brackets though, right?
No.
Oh.
You silly dog.
So -5 to -3. Let's see if you're right. -5 is here to -3. Yep, Pierre would be walking uphill. I need another one. Aiden. -1 to 1, using parentheses, -1 to 1. Let's check that. At -1, Pierre would be walking uphill until he got to 1. Awesome. I need one more. Someone new? Kate.
4 to 5.
4 to 5. Let me check that. Let me go over to 4. And at 4, Pierre would be walking uphill until he got to 5. Yep, we're good there. Decreasing. I need a decreasing. I need a decreasing from someone new. Yeah.
Negative infinity to 5.
Negative infinity to -5? Let's check. So at negative infinity, is he walking downhill? Yes, he is. All the way. Poof. At 5, he stops and hits a wall. Yep.
It slides down from infinity to hit that.
Do you know how fast he'd be going? Well,
That would hurt. Yeah.
because it's a theoretical graph, so he'd be going infinitely fast because there's no friction or anything in the...
But if we go through laws of physics, you probably never did.
All right, where else is it decreasing? Yes. 1 to 4. Let me check that at x equals 4. Pierre is here, and he'd be going uphill until he got to 5. Oh, I was doing 1 to 4. I'm sorry. At 1, I was like, that's wrong. 1 to 4 is good. All right, where is it constant? I just need one more. One more person tell me where it's constant. Someone new? Yes, Gabby.
-3 to -1.
-3 to -1. Cool. And I guess I need one more. I missed one, actually. I just saw another one that we need. We need one more. We need one more. Someone new. Someone new. Someone new. Yeah, Fatima. 5 to infinity. Perfect. All right, real quick. Your homework, the first few problems. Most of them are semi-easy. They get harder and more difficult as you kind of go. Remember, if it's like y squared on one side, do your input first. Think about what your outputs could be. Because your y, like the y, what could your outputs be? And what inputs come from there. So kind of think of those backwards. All right, to work on those. Make sure you check your answers on